Okay, I'm going to go over paper 1 from the B paper from the prelim practice then. Okay. So first question is multiplying out brackets. When you multiply out a bracket, you want to multiply everything through by the 2x to begin with. So we're doing 2x times 2x squared, which is 4x cubed. 2x times minus 5x minus 10x squared. 2x times 2 gives me plus 4x. I now want to multiply everything through by minus 3, remembering take that sign into account when we're doing this. So minus 3 times 2x squared is minus 6x squared. Minus 3 times minus 5x is plus 15x. Minus 3 times plus 2 is minus 6. Tidying up then, 4x cubed minus 10x minus 6x squared is minus 16x squared. 4x plus 15x is 19x, and we get minus 6 at the end. Okay, 3 marks for a question like that. You'll get a mark for multiplying through by the 2x, a mark for multiplying through by the minus 3, and a mark for correctly tidying it up. Number 2, we're changing the subject of the formula. We want the subject of the formula to be Q. First thing I'm going to do is rewrite it the other way. My aim is to get Q on its own. Here it's been divided by R, the opposite of dividing by R, timesing by R. So that R is going to come to the other side and become a times. Here the Q is being square rooted. Opposite square root is squaring, and I want to square everything. So you either need with a bracket in, or you need them both written as squared. What I can't accept is VR squared like this, because that just means R squared, not both of them squared. Okay, so either in a bracket or both of them squared. Okay, number 3. Diagram here. O is the centre, so there's my centre. PQ is the diameter. PQR is a straight line. RS is a tangent. And angle QPS, which is the one marked in here, is 24 degrees, and I want to find the size of angle QRS. So first thing I need to do is identify the angle I want to find. It's angle QRS, it's the one I draw around. So it's this angle here that I want to find. Okay, a few things to remember then. First thing, a tangent. Now this line SR is a tangent, and the radius, which is OS, always meet at 90 degrees. So that there is a right angle. What I'm going to do before I go any further is I'm just going to get a bigger version of this diagram to draw on. That's better. Okay, so mark back in what we'd found there then. This is the angle I want to find. That's the one I'm looking for. And I've worked out that this here is a right angle because it's a radius meeting a tangent. This triangle in here, this triangle POS, this line POP is a radius and this line OS is a radius. That means it's an isosceles triangle. Because it's an isosceles triangle, because these two sides are the same length, these two angles must be the same. So this angle in here must also be 24 degrees. Okay, now angles in a triangle always add up to 180. If I take that 48 from 180, now it's non-calculator, that doesn't mean you don't need to, not allowed to do any working, you can do as much working as you like. So this angle in here, the third angle in my triangle, must be 132 degrees. Okay. Now we were also told that this line POR is a straight line. If it's a straight line, these two angles here need to add up to 180. It's 180 degrees in a straight line. So the 180 equal 132, get back to 48. So that angle there must be 48. Now in my triangle, I've got a right angle, I've got 48, and I've got the one I don't know. I know the angles in a triangle add up to 180. So if I add together the two angles I know, I work out what the missing angle is. So this angle in here is 42 degrees. Number 4, we want to express 2y squared minus 6y over y squared plus y minus 2 in simplest form. If I'm being asked to simplify a fraction, I want to simplify it down. When I simplify down a fraction, I'm dividing. Opposite of dividing is multiplying, so I want these written as products. Another way of saying that, I want to factorise. So I want to factorise both top and bottom. Looking at the top, there is a common factor of 2y. That leaves me with y minus 3. Looking at the bottom, if you need to do some work, if you're factorising, you can do it over at the side. I've got y squared plus y minus 2. Sorry, I'm just thinking that doesn't work out for it. Simplifying down. We'll keep going and see what happens here. I want to put this into two brackets. I'm looking for numbers that multiply to make number minus 2 and add to make 1. It's got to be 2 and 1. It's got to be positive 2 minus 1. So y plus 2y minus 1. Now, what usually happens with a question like this is whatever that bracket is, cancels down with one of the brackets down here. For some reason, I think somebody's made a mistake when they've made up this question, to be honest, because none of these cancelled. So we can't simplify that one any further. It just stays as that. Number 5, we're evaluating 8 to the power of 2/3. So if I rewrite that, that is the cubed root of 8 squared. If it's the cubed root, I'm looking for a number that if I multiply it by itself 3 times, I get 8. And the easiest way to do it, if you don't know them, is just to try it out. I always start with 2, then go into 3, then go into 4. It's never really any higher than 5, unless it jumps to 10, but which case you would know. 2 times 2 is 4 times 2 is 8. Cubed of 8 must be 2. Still need to square it. 2 squared is 4. Number 6, an algebraic fraction. So we've got 2 over m plus 3 over m minus 1. To add or subtract fractions, we need to have a common denominator. When it's two algebraic terms like this, we multiply them together. Ignore that x there, it shouldn't be an x, it's an m. Okay. We then cross to get the top ones. That m's been times by the m minus 1, so that 2 needs times by the m minus 1. That m minus 1's been times by m, so I need to do the same to the top, times it by m. Multiplying out the brackets. Don't need to multiply out the denominator, it can just be left as a multiplication or a factorised form. Tidying up, multiplying out the brackets gives me 5m minus 2. Denominator stays as m bracket m minus 1. Number 8. Number 7 you could try now if you've done the quadratic work, but we'll skip it just now. Number 8, we've got two straight lines. We've got the line y equals 3x minus 2 and the line x plus 2y equals 10. Okay, two ways of doing this. I'll show you both ways. Okay, the first way to do this is using substitution, which you looked at briefly. And then once we move on to elimination, what happens is most people prefer the elimination, so they use it more often. But this one's all set up for substitution. This tells me that y is the same as 3x minus 10. I can sub equation 1 into 2. So I'm going to replace that y with 3x minus 2. Here I've got 2y, so I get 2 lots of 3x minus 2. Multiplying out the brackets. I get x plus 6x minus 4 equals 10. Tidying up. I get 7x equals, here it's minus 4. So over here it would be plus 4. So 7x is 14. X equals 2. I want to find y as well. So y is 3x minus 2. I've worked out that x is 2. So 3x minus 2 is 6. Minus 2 is 4. It's asked for a coordinate point. So my point P must be the point 2, 4. Remember, a coordinate point always goes x, then y. Number 9, we have a cost graph here, and we want to find the values of A and B. Okay, ignore this bit, that's just from a previous question. It goes up to 6, down to minus 6. It's nice and even. That means A must be 6. Okay, looking at B. B is how many cycles we have in 360. So here, I've got 1, 2, and 120. If I've got 2 and 120, and I can fit 120 into 363 times, I can fit 3 of these graphs into 360, which means B is also 6, because I would have 6 of those in 360 degrees. Number 11, last one then. We want to calculate the area of the triangle as asserted in simplest form. Okay, area of a triangle is the length and width. So we're doing 4 root 3 times 2 root 6. Numbers multiply as usual. 4 times 2 is 8. Numbers under a square root sign can be multiplied with the left under a square root sign. So 3 times 6 is 18. Then we need to simplify it down. So the biggest square number that goes into 18 is 9. 9 goes into 18 twice. Square root of 9 is 3. Then we can tidy it up. 8 times 3 is 24. So we get 24 root 2 centimetres squared. That should be a squared. Squares always end up looking like doubles. There you go, that's a bit better. Okay. Any problems with any of the questions, please get in touch.